Okay, today we'll discuss about regular expressions in detail. Okay, um, Splunk supports PCRE regular expression engine. That means Perl compatible regular expression. Okay, so we'll see some of the basic concepts and advanced concepts as well. So we'll try to cover most of these things here in this particular sheet. And also, if you think about regular expression, right? What it is, it's actually a pattern matching programming language, you can say, definitely, because it has different syntax, different engine at all. Okay, so basically the main work or the main concept behind the regular expression is to find a pattern from a text we have, right? Now, in Splunk, regular expression used in three different purposes, where it can be used in to extract a new field from a text, okay, to create a new field basically, or it can be used to filter out different events based on a regular expression. Okay, and also it can be used in our field page, new create new field, which I already said, like by creating new field, to create a new field we can always use these regular expressions. Okay, so now we'll see. So what we'll do today, like if you saw my previous video, right, where I have in detail discussed about rex, regex and erex command, right? And there I have said like how we can extract new fields from through using a regular expression, right? And also filter through it. So in this tutorial what I will try to do is, we will see some of the Splunk queries, but we'll mainly consider on the different kinds of regular expressions we can build up. Okay, so to do that, let's start from the beginning. Like, so if you see here, this is a PCRE chart. I have it, right. So it lists down all the different syntaxes and different expressions you can have in for PCRE. So let's see, suppose, and I have this regex101.com. So there you can test out our regular expression. Okay, so if you see dot matches any characters except new line. So suppose, let's say I have a I have, let's say my name Siddhartha KIBORTY. Sorry, maybe this is Diwali season in India, so you may find some noise outside. So if I said dot, okay, if you see here, so okay, you need to make sure that you have selected PCRE here. Okay, now if you see the matches over here, right, so it has matched all these single digits, single letters over here, right, except the new line here. Okay, it did not match the new line. Now let's move on. Any character, if I just give any character, let's say I, so it will match that particular character, let's say D. Okay, now how it matches, let's discuss this first. Okay, so at the granular level, what it is happening is, any expression you give, regular expression, the regular expression engine trying to apply that expression over here on the string you have provided. Okay, now if it is finding a match, that means it's a success. Okay, so what it will do, so until and unless full regular expression is completed, it will try to find that match. If it is finding that match, it will say, it will save that result, okay, as a occurrence, as it will save the result. Okay, then it will move on to find the new next pattern, next match. Okay, so this is how it works. So that's why if you see, just when I have given just D, it matches two things, two D's over here, right? If you see at the right side, there are two matches happen. For the first match, when it happens, it exhausted the full regular expression, right? Then it forgets everything, then move on to the string, and then matches again the next D. Okay, so maybe if you see A, now if you see four times it matches, right? How? Because the first time the full regular expression executed, it matches the A. Then it move on to the other letters. It did not found any match. That means regular expression is failing over there. Then again it found a match over here. Like that, the regular expression works. Okay, so that means if you give a full paragraph, it will give you all the different occurrences. Okay, we'll see in Splunk as well, like how we can get the occurrences as well. Okay, so let's move on. AB, the string AB, it matches, so it is very easy. Like suppose let's say THA I want to match, so it's just THA, normal stuff. So let's move on. A pipe B. Okay, that means it's match either A or B. It's a or condition. So suppose I want to match, let's say, let's now try to mix up the things, right? So suppose I have a um, RA over here, right? So let's say HAR RAB. So let's say I have want to match HAR and RAB. Okay, so how you'll match? I have a single dot, right? That means it can match any character. Then what I will do is I have a after that. Okay, if you see, now if you see, it is matching this HA as well. Now after A, I want to either I have R or B to match HAR and RAB, right? So to do that, I will write something like this: R or B. Okay, so if you see, it found the two matches now. Okay, this one. Now let's not give this bracket here. Okay, because the bracket means something else, which we'll discuss later. Okay, now if I don't give this bracket, what is happening? If you see here, it's only matching HAR because a single character and AR it is considering together because of this rule. Okay, so if I give bracket, I'll tell you the bracket, what is the meaning of this bracket. It's a basically concept of group, which we'll be discussing later. Okay, so basically what I wanted to show you over here is it's or condition it is executing. Okay, now let's move on. A star, that means zero or more A's. That means it is basically determining the repetitions of A. Let's say I have a string like this, A. Okay, now if I give a star, it is matching basically all the A's. Now it is also matching an empty string if you see it here, because it's either zero or more A's. So we need to keep in mind that. Okay, it's basically making this particular A repetition as optional as well. Okay, let's move on. Escapes a special character. Okay, now let's take an example. Let's say I have an equation something like this: 1 1 plus 1 1. Okay, remove this one, equals to, let's say, 22. Okay, now I want to extract 1 plus 1, this string, from here. Okay, so now how I will do it? So to match this one, what I will do, I will have a 1, right? Then I will have a plus after that, then I will have a 1. Now if you see, it is matching 11, not 1 plus 1, because plus have a special meaning there. And if I try to find it, plus means it's a quantifier in regular expression, where you can say a particular string or a particular group or pattern is repeating one or more times, right? So regular expression Indian is stating it as the same way. That's why it is matching 11, more than one repetition of 1. That's why it is matching 11. So to get this string 1 plus 1, what I need to do, I need to escape this meaning of this string, right? So if I escape now with this one, so it is now matching 1 plus 1. Okay, so this is how you escape a special meaning of any of the regular expression. Now let's move on. Now quantifiers means, as I already told you just now, plus is one of the quantifier, where you will say, you will basically quantify the regular expression pattern, like the how many times it can occur. Either it can occur 0 or more times, 1 or more times, 0 or 1 time, exactly 2 and 5, like this. Okay, in any number. So let's say I want to verify whether my password is 8 characters length or not. Okay, so if I say, if I give a regular expression something like this, okay, dot, okay, any character, let's say, now I will not apply any other rule except that I will just apply this rule. Now I'll give this regular expression as 8. Okay, so that means it will, any character, it will match in 8 times. That means my string length has to be 8. So if I give this one, it is no match, jk. Now it is matching because this is the 8 length character, 8 length word. Okay, so this is how you can check the character length, total word length as well. Okay, whether a particular length is there or not. So if you see 8 is the one of the quantifier here, so it is exactly 8. Now if I just to say, if you just to get the range, let's say 8 to 10. Okay, so this will also match, this will match, this will match, but if I exceeding 10, it will not match. Okay, it will only match till this point. Okay, and it will not match at all when it is less than 8. Okay, now if you don't want to keep any upper limit, you just give 8 comma something. Okay, now let's see this one. Let's say this one. Okay, this question mark. Suppose I have a string something like this, a b b b. Okay, now if I say a, then this one. So what is happening is I am matching all the a's occurrence, right? If you see, all the a's occurrence either 0 or 1 time, that means it is all the single a it will match. And also, if it is, as this is 0 or 1, right, that means if it's also matches those string where a did not appear, that means it makes this particular regular expression optional, right? Regular expression is this one, it's fully regular expression, but whatever coming before this question mark, it's making that particular expression optional. That means if it is occurring, then it's fine, it will either occur one time match. If it is not occurring also, the regular expression will not fail. Okay, that's why if you see this boundaries, this red colors one, it did not match b, but in between a and b it is matching. Okay, so this is about quantifiers in regular expression. Now let's talk about groups, because groups play a very important role in regular expression. Also for Splunk it is very important, because when you want to extract a new field from a by using a regular expression, what you need to do is you need to create a named group basically. So what is group? Let us understand that first. Okay, so let's say I have this string only. Okay, and I have something like this. So when you create a group, right, you create within this first bracket. Okay, now if I say a, okay, so that means I am considering this whole thing as a single unit. Okay, so that means if you see here, the matching is happening with AA, but the group name is also AA here. Okay, now if I say AA exactly 2 times, so the full match is happening with AA, but the group is still AA because AA is acting as a unit. Okay, so when you create a group, two things happens. Okay, so basically when you create a group, specifically the named group, you can give it a name. So this is how you can give it a name like this. Let's say test. Okay, so what happened, by using this name you can recall this group. That means when the regular expression engine encounters this particular regular expression, this saves the group output. Okay, now I'll show you how to do that as well. So basically the main logic behind the group is when a regular expression engine encounters a group, specifically the named group, it not only calculates the group this way, it also saves the group output. Okay, not the group regular expression, the output. In this case, it will be AA. Okay, so that you can latter stage of the regular expression, you can refer it. Okay, let me show you that one as well. Let's say this is how you refer it. Match the named group Y, right? This is how. So if I just give test, my named group, right? Group name I have given test, right? Now if you see here, what is happening? First of all, it is matching AA, right? With this one. Now, second thing is I have called this test. Now, what is this test matching? It's AA, right? That's why it is matching the AA again. Okay. Now, if I give something like this one, let's say after AA, if I have something like A, AB, okay. Now, if you see here, sorry, AB, okay. Now you see, if you see here, there is no match happening here. Okay, why? Because the first one, it's basically having this one, right? It's matching AA, single AA, right? Now this is the output of this group, which is stored somewhere in the memory. Okay, now again I have called this test here, so it is trying to match again another AA, which it is not able to find in this string. Okay, that's why it is not matching anything. So this is how you create a named group. Now named group play a very important role in the Splunk. So maybe I'll just show you over here with this example only. Okay, let's say I have make results. Okay, let's say I have a string like this, test equals to this string, let's say a b. Okay, so now if I give this string here, okay, so my command is rex, right? I have to give the field name. Now field name is test, then I have to give my regular expression here, right? Now if you see, it is matching the A just like this. Okay, now it's a group matching. If you have to remember that one, it's creating a new field with the whatever matching is happening with the group. Okay, now if you want, let's say if you want to do the full match, so in that case what I need to do is basically I want to create the group with this A only. So what I'll do, I'll just wrap this thing inside another group. Okay, now if you see, my group 1 is becoming AA. Okay, so I'll give this name to this one. Okay, so I can move this test outside now to name this group. AA is the group, and okay, let me go back there. So this is my group 1, and if I give another name, let's say test 1. Okay, yeah. So if I give this string here, okay, so now I can capture this 4A as well. Okay, so if you see here, you can create group as many as you want based on your need. Okay, so now let's say I have a string like this, here as well. Now if I see, it is only giving me the first occurrence here, right? It is not giving me the, because there is a match here as well, right? So to get all the occurrences, what you need to do here is, there is another parameter called max match. Okay, if you give, you can give any integer. If you give 0, that means unlimited match. Okay, that means all the occurrences it will give here. Okay, so you need to remember this one as well. Now let's move on. So we discussed about how we can create a group, how we can create a named group using this name, and by this named group only, whenever you are using Splunk rex command, you have to give a name to this group, otherwise it will not work. So if I just remove this one, so this, even though this is, it's a valid regular expression, sorry, there is another name here, regular expression, but there is no name, so it will fail. Okay, so let's move on. Now I have this example, right? Let's say I have this example AA. Okay, so what we have done is, we have created two groups here. If you see, the inside group is the, it's actually matching this AA. Now let's implement it in different way. Okay, so let's say I want to match this AA as a group. Okay, now so it is basically creating, if you see, two matches with this group AA, but my intention is to get this AAAA fully. Okay, so what I'll do is, I will give this one. Okay, okay, so what is happening is, so I give a quantifier here, right? So my full match is AAA, but my still group is AA. And as I show you earlier, whenever you are using this one, this group name, named group, it will capture only AA, it will not capture AAAA, right? So let us see how we can capture it. So to do that, we used to give a name over here, right? A name like test. And what we have done earlier is, we basically wrap this up inside, so that my group 1 is becoming a now, right? And we have given a new name here, test 1, right? So we are basically capturing the test 1, not the test. Okay, so now if you see, there is another concept called non-capturing group over here. If you see, non-capturing group. Okay, so now, so non-capturing group means these groups will not be saved. That means the results will not be saved. That means you cannot back reference that group at latter part of the regular expression. For the named group, as I show you earlier, right, you can back reference it using this one, right? Match the named group, you can call it again. But for non capturing group, you cannot call it again. Okay, so to do that, I can just do something like this. Okay, so if you see, I just vanished this test group here from here, right? So it just only test one will be stored in the computer memory. Okay, so by doing this, what I am achieving is the regular expression execution will be much faster, because the inside group I do not need at all. Okay, so if I just use this one in my query, okay, and my string is that one, so it will capture only the this one. Okay, so let's move on. Let's discuss about atomic grouping. Okay, atomic groupings are very interesting. Let me show you one regular expression. Let's say I have a regular expression something like this: A, B, C, or B. Okay, C. Okay, so what are the strings this will match? So what is this regular expression is talking about? I have a letter called A. After that I can have either BC or B, right? Suppose let's say BC, then I will have C. It will match, right? So it will also match ABC, if you see, because this is either BC or B. Like, let us understand how this regular expression engine works here. Okay, so my regular expression is this one, right? And my given string is this one. Okay, so okay, better I will give the string ABC. It will be easier. So how it will work? It will first match this A with this A, right? Because this is the first string in our regular expression, so it will A is matching with this A. Then regular expression engine is entering to this one. This is a OR condition, right? Either BC or B. So it will check the first condition, BC. It is finding a match over there. Okay. Then when it is finding a match, it is coming out of this OR condition. Then it is trying to match C. Okay. Now there is no C over here, right? Because BC already matched that C, right? So that means regular expression engine is failing over here. Okay. But it knows it knows that there is a OR condition over here. That means it is basically saving the state there. Okay, so that's why it is again going back inside. Okay, checking the other condition, B. Okay, then B is matching with only B later over here. So I got a match of A and B. Okay, then it is coming out and finding the C, and that's why ABC it is able to match. Okay, so that means whenever a regular expression engine going inside a okay, group, it is basically saving the states of the group. If the group is having lot of different OR conditions, the regular expression engine always try all the different combinations possible over here, okay, to find a match. If it is not able to find a match, it fails, but it will definitely try all the possible combinations. Okay, so we saw it. So we saw over here, right? All the possible combinations we have it: A, B, C, C, and ABC, right? These two conditions. So if you see both the string, it is matching over here. Now suppose we're talking about atomic grouping, right? So atomic grouping basically restricts this thing. So if you want to if you don't want to match all the conditions, you just want to match some of the conditions, you can use the atomic grouping. Now atomic grouping is non-capturing in nature. That means the value of this particular regular expression will not be stored in the memory as like our named group. So this is how you create atomic grouping. Now if you see, let's see how it is working. So if you see, now it is not matching ABC. Why? Because the behavior has been changed now because of this atomic grouping. So atomic grouping means, as I told, it did not save its result there, right? So accordingly, when according to the previous logic we have discussed before, whenever it founds a match of A, then match of BC over here for ABC, it's coming out, and it saw another C there. So it is not, there is no other extra C over there. If it is extra C, it will match, but there is no extra C over there. So it is not matching, but it is not going back inside because it did not save its states. Okay, so this is the difference between atomic grouping and normal grouping or named grouping basically. So atomic groupings are basically, you can think of it as a restricting the number of possibilities of a regular expression. Okay, so you can, based on that, you can match as well, and it is faster compared to the normal grouping as well. Okay, so this is the concept of atomic grouping. I think we talked about non-capturing grouping, capturing grouping, or named grouping, especially capturing group. You can give it a name. uh, we saw like how to match a name group. Similar way, whenever a group has been created, right? So the group name, okay, let me remove this grouping now. Okay, whenever a group has been created, the group has been have been assigned a named name over there or number over there. So you can, as I told you, for a capturing group, you can refer it back either by the group number, like this slash the number, or by the group name, is just like this one. Okay, now let's talk about recursion. Now recursions are another interesting aspects of regular expression. Okay, let's say I have a string something like this, a z z z. Okay, so recursion means if you have a regular expression and recursion. Now recursion means whenever a regular expression finds a recursion tag, it what it is trying to do, it try to rerun the regular expression again, just like our normal recursion works, right? Recursion program. So let's take an regular expression. Now recursion you achieve through this one, okay? So let's say I am giving this regular expression. R is my for recursion, this one Z. Okay, it is matching this one. Okay, let's analyze this, how it matches. Okay, so to do that, what I'll do, I'll go here. Okay, now this is my regular expression. ZZZ is my string, right? Now let's see how it is matching. So when the regular expression finding that first pattern, it's A, it's matching with this A. Okay, so my first match happened. Now it is finding this recursive pattern, right? So that means it is trying to execute this whole regular expression again. So according to that, it is matching with the another A, right? Because it is finding the A. So my second is A is also matched. Okay, then again it is so this is in recursion 1. We'll note it down, recursion 1. Okay, so it is going inside a recursion. Okay, we have to understand that. Okay, so now the second day has been matched by recursion. Now when the second day has been matched, in the inside the recursion itself, it is getting another recursion here, right? So again it is trying to match execute this full regular expression on this string. So it is finding another A, recursion inside recursion. So this is recursion 2, right? Recursion 2. Now recursion 2 also having, after matching this A, also having this one, right? That means it is again trying to run execute this whole regular expression. So first thing is A, but in this string there is no A. That means this is failing, right? This recursion failing. But if you see here, I have given a question mark here. Now let us go back to our cheat sheet here. So question mark means 0 or 1. As I have discussed before, question mark makes that particular expression optional, right? If it is present, it will match one time. If it is not present, that is also fine. So that's why the regular expression will continue. It will not be considered as a fail. Okay, it will continue, and you will find another pattern Z. So that's why it will match this Z. Okay, in recursive 3. Okay, so now if you see, it has executed in recursive 3, it has executed the full regular expression. Okay, but at the recursion level 3, so it has to now backtrack because it is inside the recursive mode, right? So it has to backtrack now. So how it will backtrack, because it will now go one level up, then one level up, just one level up. So it will now from 3 to it will move to 2. because 3 is already completed now and we are in recursion, right? So we have not completed the full cycle. So in 2 only what is left, z part is left, because it's already matched this part, right? So again it will match with z in recursive 2. Okay, again when it moved to recursive 1, again only z part is left. So again when it is moving back to recursive 1, it is again matching another z. Okay, and again when it's moving back, so it is finding all the z's over there. So this is how it works, the recursion. So it is going, whenever it's finding recursion, it is going inside and inside, basically like a stack. Whenever it is coming out of recursion, it is unstacking it. Okay, so let's move on to this. So we saw how recursion work. Now to make it in Splunk, you just need to make it as a named group. That's all, it will work. So let's talk about now. Recursion can be, you can do recursion for a group as well, right? So in this case, if you saw here, instead of a, it can be a group as well for recursion. The same thing it's happening over there. Okay, so it is basically executing the same group again and again, similar way. Now similar way, I think these are all the same concept over there. Now let's move on to some basic concepts like character classes, where if you do something like, if you have a regular expression something like this. Okay, so let's say I have something like this, a, b and t. It will be inside a square bracket. It will be inside my square bracket, right? So if you see any of this character, either a, b, c or d, this c is missing, but you can give a dash over here. So it's basically a, b, c and d. One of it will match, so it's only matching this a is. Okay, this is very simple one. Similarly, if you don't want to match a, b, c, d, you have to give a hat over here before that. Okay, if you want to match a backspace character, you can do this one, digit character slash d. Okay, non-digit character slash capital D. Simple. I think these are all the simple one, like word character space white space. So let's move on to regular expression assertion, where asserting means you are asserting something, right? So you just give a condition, it tells you whether it's true or false, something like that, assertion, right? So inside the assertion, I think most of you know this thing. This hat is uh, basically states the start of a string, and this dollar is basically states the end of a string. Okay, now there is another thing called slash capital A and slash capital Z. Those are also start and end, but these are like M flag, and if you see the M flag here, it is the multi-line flag. Okay, now let's talk more something about look ahead and look behind. Okay, this is something interesting. Hmm, so look ahead and look behind means whenever I have the regular expression engine got this look ahead and look behind, it's basically from the current position, it's either looking ahead or looking behind. Okay, so now let's take an example. So this look ahead and look behind are basically used to determine certain conditions, like suppose I have a string, let's say something like this. I want to check after q I have a or not. Okay, so if this is my string here, okay, and I have a regular expression something like this. So if you give the regular expression after that, if you give this look ahead means like this one, right? So I have to give here. Okay, let's say q, after q I want to check a is there or not. Okay, so as my string has A after Q, so that's why it is giving me only Q. It is not giving me QA. Okay, we have to remember this one. Okay, it's basically regular expression is getting a success, is a match, but it is not matching the A. It's only matching the Q, but it is checking a condition whether A is there or not after Q. This is look ahead. Okay, and this is called positive look ahead because I am taking the positive condition. And if you see the look ahead negative, okay, after question mark there is the instead of equals to, it will be exclamatory. That means if A is present after Q, then the regular expression will fail. There will be no match. Just opposite of positive look ahead. Okay, now look behind this, you are basically giving a, you are basically looking the behind. So in that case, this regular expression will be at the left side. Okay, look behind expression. Okay, so here I am checking whether QA is present before Q or not. Okay, now look behind is this one. So let's copy that. Okay, and let's say A here. So if I say AQ, now if you see it is matching, right? Because A is present before Q, and that's why when it's matching, it will not give the look behind expression. It will not give that matching character. It will only give the other character for which you are matching basically. Okay, so similarly, if you don't want to match negative look behind, you just need to, we are basically taking the we are basically checking the condition where A is not before Q. Okay, similar way. Okay, let's move on. So flags, I think it is very easy to do it. We just like ignore case and multi-line characters or matches new line or not. This is simple in nature. Now there are certain some special characters like new line. If you want to match new line, let's say let's say Siddharth. Okay, and Chakrabarti. So if I give simple black slash in, okay, so what it is matching, it is matching this new line. Okay, similarly for other like carriage return tab, you can use this character to check a octal number, hexadecimal number. You can use these expressions. Okay, these are also very easy in nature. And I think regular expression classes is also very easy in nature, where each and every class determines what kind of range of digits, numbers, letters it is basically considering. Suppose alphanumeric, it's only considering the letters and digits, right? So this is how you use a class. Okay, so let's say I have something like this, a b c, okay, dollar hash this one. Now if I copy this one, there is a special consideration we have to do. Okay, now you have to wrap this up again within a square bracket. Okay, to use this particular in any of this class. So now if you see, it is not matching this dollar hash at the rate, it is matching this abc. Okay, similar way for alpha, it is only matching the letters. ASCII, it is all ASCII character is matches. Blank, it's all space and tab character it's matches. All control characters, you can use this one. So similar way. So if you want to match only the digits, you can use this digit class. Okay, so these are very self-explanatory in nature. Okay, so we almost discuss about some of the basics and some of the advanced concepts of regular expression. um, let us take a use case. Okay, so suppose I want to this is a real world use case, right? Suppose lot of websites have this password policy, right, where password length has to be something like some length, right? And then there has to be two, let's say two uppercase and one special character between this one, okay, among this one. and some numerals, let's say two numeral character among this 0 to 9, and three lowercase letters. Okay, so I want to build a regular expression to check all these conditions. Okay, so let's say I have a password something like this, AA. Okay, so this is having two uppercase, one special character, let's say at the rate, let's say two numerals, let's say 2 3, right? This is I'm just trying to build a perfect password, and three lowercase letters, let's say ABC. Correct. So total length is 33628, right? So this has to match. This is a perfect password, but this may not be a perfect password, ABCDEF, because this is not even 8 length and it does not meet all these conditions. So let's build a regular expression to do that, right? So I already built that one, so I'll just explain one by one. Okay, so we will divide this whole thing into small pieces. So as you have seen before, this hat is basically matches the beginning of the string, right? Hat, start of the string, right? So hat, and this dollar matches the end of the string, right? Now if I just give dot, then inside this one 8, so what I am saying, what I'm basically checking is I am checking my string length is 8 or not, right? Dot matches any character, and 8 inside this curly bracket matches the number of times the single character we can occur. Okay, so now I already verified this one, right? 8 characters length. So let's verify the uppercase letter. For that, what we'll do is I just need to verify it, right? Whether there or not, because I already constrained by this regular expression. I already constrained the 8 character. Now I just need to see it whether a particular two cases is there or not. So for that, what we'll do is we'll look ahead, as I have seen before, right? Look ahead. The look ahead expression does not return by the regular expression. They just check that condition, asserting it, right? So, so to do that, what I'll do, I'll just copy this one. Okay. So before that, I'll this one. So what I am doing, this is for the look ahead, positive look ahead, and this is my regular expression. It is very simple one. It's a single character. It can occur, star means 0 or any time, unlimited times, right? Now I am say giving this range A to Z, and similar expression again. Okay, so let's talk about this one. So this AA, right, two uppercase can occur any places, right? Either they can occur together, or it can be occur, this A can be here, something like this, and then this A could be somewhere else. This A could be somewhere else, right? So that's why, and there could be, it may not start with A. It could, the A, it could be something like this. Copy, Control V. It could be something like this, @ AA, right? It could be something like this. So that's why this regular expression has been written. So any character, 0 or any time. So I have given star because of this condition. This has to match. If it is starting with capital A, then the star is actually making this particular character optional. So it will start with capital A. Okay, capital letter of anything. The same thing has been repeated over here. Okay, so basically this particular regular look ahead is checking whether I have two uppercase or not. Okay, similar way I have checked for this one, special characters, a single special character, that's why only one occurrence here. Okay, again look ahead, and if you see under inside the square brackets means I am using this one, right? One of the character it will match. Okay, and similar expression as I explained before. Then I have two numerals, that's why 2 times. Okay, two numerals I have. So if you see this thing, these passwords are matching, this is not matching. And then I have three lowercase, similar concept. Okay, so if you see this full regular expression is matching this password, that means these passwords are valid one. Okay, this password is not. Okay, so this is how you use regular expression to determine anything. Then regular expression can be used in different purposes, like to validate the email address. This is one of the use cases, right? To validate an HTML tag or an XML file, whether it's a proper XML or not, you can do that using regular expression. Okay, so this is the different these are the different use cases of regular expression I can think of. Hopefully it will be useful for you guys. See you in next video. Thank you.